Hi, welcome to the Calculus 3 lecture series. We are in the unit talk about the vector calculus, and we are in the lecture number 5. This is the second video for the lecture number 5. We'll talk about the fundamental theory of the line integrals here. Okay, so let's let's take a look at what we did for the first video. Let's do a very brief review, then we can start our second videos here. All right, let me go to get our lecture notes here. Okay, so this is what we covered from the first video. We talk about, we talk about the fundamental theory of the line integrals. Then we talk about one very key concept about the conservative fields, right? So we say, what is a conservative field? That means if your field vector, capital F, if the capital F is some gradient vector for some function F, then we say the F is a conservative field. And then we say the conservative field, then if you want to take the integration over the conservative field over the line integral, then is the independent of the path. That means wherever, like if you have this is a path C1, and if you have this is a path C2, and if you have this is a path C3, if they all start from A to B here, and then under the conservative field, when you do the line integrals, they all be the same. Then the last is from the last video, we say, how do we test a conservative field? Of course, if you can find the functions whose gradient vector is equal to this one, then we say this is a conservative field. Or the other ones here, we know the f of xy, this is quite a very useful. So we say that this one here is the pxy to the I components, to the qxy, to the j components. So we say if the rho p, rho y is equal to the rho q, rho x, then we will say this field is a conservative. Okay, so today we're going to, the things we're going to focus on is, if you give me a field, and how do I find the, if they say this is the gradient field of some function. So we're going to go backwards, say how do we find this f functions here, the lowercase f functions here, okay? Okay, so now let's go ahead, think, okay, so let's take a look at this. This is the, we did the first 7 problems here. This is the problem where we start. Let's try to do it. So let's say, okay, so if I know I want to find a function and whose gradient function is xy squared plus 1i and 2xy plus 3y squared. Okay, so the first, let's try to write here. So the gradient function is really just what? The partial derivative to x and the partial derivative to y here. Okay, all right, so now let's see here. So also, let's try to highlight this one and this one, okay? So this one's here, this is my pxy functions, right? This is my qxy functions here. Okay, so now the first things here is like we said, okay, so f of xy is here, right? So this one, so that means this is what the partial derivative for x, right? Then by using the integration, so I know that means I'm doing what? I need to integrate because the pxy is the partial for x, right? So that means I will have the pxy here. Then what I need to integrate back? I need to integrate back to the variable what? Variable x here, right? Because here I took the partial. So you take the partial derivative, now you integrate it back. And then this one's here is will give you, so what is pxy? Is y squared plus 1. And what is dx, right? Okay, so you just apply the, the typical, we did the antiderivative, because right now I'm looking for the integration for x here. So what is y? Y is a constant. So I have y squared x plus x. And now I'm plus c, right? Because this function is f of xy, so I'm plus h of y. So it's kind of like the c, like when you do the indefinite integration antiderivative, you have c. So these numbers here, right? So this is a similar like what? Similar like the integration we call this the c's, right? Okay, plus c's here. Okay, so now this is the f of xy. Okay, so if this is f of xy, now if I take the partial, I will get f of y's, right? Okay, so now I will say the rho f, right now, I'm taking the partial for y, right? So what is this one give me? This will give me f of 2y, right? It's a partial derivative. Okay, so now if I take the, this is a 2yx. So what happened here? X disappear, right? So this is h prime y. Okay, so what is f of y here? The f of y is qxy. Am I right? Okay, so this is the qxy here, right? So I'm going to compare, because this one here is the qxy. So the qxy here is 2xy plus 3y squared. So what I have here, so because here you compare to these two, right, it should be equal to qxy. So what I can conclude, my h prime y is what? My h prime y is what here? Will be 3y what? 3y squares, right? You compare that. So this is a 3y squared. Okay, so if this is 3y squared, now I want to find the hy, because f of xy is plus hy. So I can say the h of y is equal to what? Is integrating 3y squared, because this is check derivative of y's, right? So I need to integrate dy back. Okay, so now when you integrate dy back, so this will be y cubed plus another constants, right? So I say constants k. So now I finally, see here, right? So here, this is the hy. I can substitute back to whatever is here. So what I have here, so I have my f of xy here from these equations. So I can say is y squared x plus x, and the plus hy is y cubed plus k here, right? So can k be the constants? So I would say, how about I let the k equal to 0. So now I find my f of xy. What is here? So this is xy squared plus x plus y cubed. Okay, so now if you take the partial f of x, f of y will give you this field. So I know, that if your field, if your capital F of xy defined as this field, then capital F of xy is conservative, because I can find a function and whose gradient vector will be equal to, the whatever we have in the fields here. All right. Okay. So now let's take a look at the problem number, the next practice problems here. Okay, so our next problems here. So we said C is a parabola from the x equal to y squared from 1, 1 to 4, 2. I want to evaluate these line integrals here. Of course, in here, what you can do is here, right? You can just put into a parametric form and then substitute it here. All right, then you integrate will just be the one's value of t. So now let's try to see the different approaches here, right? So here, let's see here. Let's this is what this is here, right? Okay, so let's say here, this is my pxy. This is my qxy here. Okay, so first things here, I said rho p rho y. So rho p, rho y, is 6y. And then I said rho q, rho x here. What is rho q, rho x? 6y also. Okay, so great. So these two equal. So we know if rho p, rho y is equal to the rho q, rho x. What I conclude here, I conclude what? So the f of xy, this one's here. So I conclude, let's put it here. So I can conclude here, my f of xy from the, so if I define it as 2x plus 3y squared, I plus 6xy plus 10j. So I can conclude this is what? This is a conservative. Okay, if it's a conservative, then it's a path-free, right? So it's independent, not a path-free. So if it's a conservative, so it's the independent of a path. That means I can just plug in these 2 points into my, it's independent of the path. So if I can find the what? If I can find the f of xy, lowercase f of xy, then I can just what? Plug in, right? Plug in the beginning, the starting, and the ending point, right? Okay, so now let's try to do one more time to see if we'll be able to do that. Okay, so the first one's here. So this is f of x, this is f of y. So I'm starting, so I said f of xy, because this is f of x, so it will be the integration of the 2x plus 3y squared. So I'm integrating to what? dx, right? So I have x squared plus 3xy squared, correct? For 3xy squared and plus what? H of the y is my c values, right? So now I'm taking, by try to match the f of y, so I'm taking the partial for y. So the x disappears. So what is here? This is 6 of the y plus h prime y. I know the f of y is equal to what? Qxy, right? So it's equal to the Qxy. So I want to compare to the Qxy. So Qxy is 6xy plus 10. All right, so what I conclude here by comparison, I can say my h prime y is equal to what? Equal to 10, right? So in order to find this f of xy function, I need to have hy. So what I need to do here, so the hy, so what I need to do, I need to integrate back, right? So h prime y dy. So that means this is the 10 dy's, right? So what I have here, I have a 10y plus a constant k, correct? Okay, so now I can substitute this one back to here. So now I can say that my f of xy is equal to x squared plus 3xy squared plus 10y plus k. Okay, so now I will let the k equal to 0. Then my f of xy will just be the x squared plus 3xy squared plus 10y. All right, so because this is the path independent, so I can say C, the P dx plus Q, the dy, because it's path free. So by the fundamental theorem of the line integration, so this will just be the f of xy. Then what you substitute here, you substitute from 1, 1 to 4, 2 here. see here, that's why you can see here that my f of xy is x squared plus 3x y squared plus 10y. Then you substitute the 4, 2 and 1, 1. It's just like what we did in the calculus 2, right? So that means you can substitute the 4, 2 minus 1, 1. So what you got here, okay, so this will be the 84 minus 14 is equal to 70 here, okay? So that means, you know, the C here could be any smooth curve between, doesn't have to be parabola, any smooth curve between. So, you know, 1, 1, starting the same point, end at the same point. Then when you do the integration, it will give you exactly the same back, you know, the same answer because it's the path independent, right? If it's a conservative field. Okay, let's take a look at other ones here. So this is a 3 dimensions, right? So I want to evaluate, you know, this 3, C is the path from 0, 1, 1 to 3, 1, 6. So in here, you see it did not even give you the what is the path looks like. Just say C is a path here. So here, this is the, okay, so now I have, let's try to write it down. So what is my PXYZ? Is 1, right? Okay, now what is my QXYZ? Is Z. And what is my RXYZ? Is equal to what? It's Y, right? Okay, and now, okay, so now, okay, so the same ways here, right? So these ones here, I'm looking for the del F, but this is 3, so I have f of x, f of y, f of z, right? So I'm just do the integration. So the first thing is here, so f of xy, z. Okay, so I'm integrating the p, right? Pxyz, and but the p you get it from the take the derivative of what is a partial x's, right? So just like we did, so what you need to integrate back, you integrate back the x's here. Okay, so now p is 1, so it's 1 the dx. So what do you integrate back? So it's x. So x is a variable. So what is the yz, man? Yz is some constants. So you have some function, I call it constant function, but it's combined with variable y and z because y and z, if you integrate x, y and z, you can treat it as constants. All right. Okay. So now, okay, so we know the f of the y, right? So f of the y is the what? It's a partial derivatives, right? So now the f of the y is the, you take the derivative for which ones here? For this ones here, right? F of y. So let me use the color coding. So we will be okay. So x is what? So this one's here, the x will be, so if you take the derivative of y, x becomes 0. Now what is this one's here? So you have a partial for y to the yz's here, correct? Now what is f of y? F of y is here, it's a q. So that means f of y is equal to what? Is equal to q, right? So the q is equal to z here, right? Because the maybe the, so this is q x y z, right? Because you take the partial derivative, it's always like integration, derivative, integration into derivatives, right? So partial derivative would be cyz, and what is the cyz? It's going to be equal to q equal to z, right? Okay, so now what I need to do, see here. So now I need to do is I'm going to, okay, so this is cyz, right? It's equal to z, and so I need to integrating. So I want to integrate the cyz. I need to integrate back. right? So I'm integrating here. Okay, so the CYYZ and what I'm integrating y's, right? The y's here, because here this is second one is y. So CYZ, as we put it here, let me color code that for you. So it's Z. Now, because the Q, you are integrating dy. Okay, so now what do we have here? So you have YZ. Okay, so you have YZ, so you integrate the Y. So then you will have another what? Another function of the DZ here. Okay, so now let's take a look at what we have here. So this is just, so I substitute this one, boom, back to here. So what I get here, so I have f of x, y, z is equal to what? Is equal to the x plus y, z, right? So I have a x plus y, z, and plus d what function of the dz here. So I do one more time, right? So now I'm do the partial derivative for z. So what happened to the x here? X is disappear. So I have y left. Now what happened here? This is d prime z. Okay, so now I have one extra d prime z. So now I need to do what? I need to integrate back, right? So I say, okay, so the fz is here, right? So compare fz, this is the one is equal to what? Rxyz. So what is the Rxyz? Is 1. Oh, so you compare that. So what you have here, you got a d prime z is equal to what? Is equal to 0, right? Okay, so d prime z equal to 0. Now I'm going to get my dz. Now I finally can find my functions, right? So the dz will just be you integrate back d prime z. The d prime z is 0, and the dz. So, right, so if d prime z is equal to 0, I know the, okay, so the d prime z is equal to 0, so I know the dz's here will be what? Okay, so I know the dz's here will be what? Will just be the 0 plus case, right? Okay, now finally I have this terms here. The dz is 0 plus k. Now I can boom, 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 back to here, right? I can get the f of x, y, z is equal to the x plus y, z plus what? Plus k, right? Now I can let the k equal to 0. So what is my function f of x, y, z? X, y, z is x plus y, z. Okay, and now because this is the conservative field, because I can find this function, so I can write this one as c the dx plus z the dy plus y the dz is the path independence, right? So it's f of x, y, z now from the 0, 1, 1 to what? 3, 1, 6. So basically you just say the f of x, the 3, 1, 6 minus f of the 0, 1, 1. Okay, so you can plug the xyz into the fxyz function. So you will get this is 8, be the answer here, right? So that's why you find this function, right? This is super important, right? You find the f of xyz function. Then because of the path independent, you just use the fundamental, the theory about line integrals here. Okay, so the method, the method is pretty routine. You take the derivative, you integrate it back, you take the derivative, you integrate it back till you can find your function, right? So that if you have x, y, z, w, then you might need to do several times, right? Take a derivative, integrate back, take a derivative, integrate back here. Okay, so now let's take a look here. All right, so I have a vector field, right? So this vector field is 1 plus x squared plus y squared here, okay? And the 2y and the 2yx plus 1, right? So this is my I component, and this is my j components here. Okay, so let's see here, right? So without doing mathematics, let's take a look. You know, like I graph this field. Does this field appear to be conservative? Well, so let's see here. So I say, okay, so if I start some closed curve, right? If this is my C, closed curves here. So from this closed curve, so like here, like it seems like this part, you are going at the same direction like your force, right? So this one you have the positive. And then like in this ones here, you seems like you start to go, okay, so I should say my line, my curve go like this way, counterclockwise, so right, okay. So then the other part here, right? So you think like, because my curve is go this way, so that the green one seems is go opposite of your force, the vector. So one part is negative, one part is positive. So when they add together, that is equal to 0. So that's probably to be conservative, because we know, you know, in the closed interval, closed curve C in the domains fields, right? If it's equal to zeros here, that means the change is conservative, right? There's a net change is conservative. So let's take a look. Okay, so from the graph, that's what that means. So let's take a look. If this is my pxy, this is my qxy. Let's do a mathematical way to see we be able to prove it, right? So the mathematical way we say rho p, rho y. What is rho p, rho y? One is constant, x squared is constant, is 2y. Rho q, rho x. Rho q, rho x, qxy is 2yx plus 2y, right? So you take derivative of x is equal to what? Is equal to 2y. Arbiter 2y equal to 2y. So we know if rho p, rho y equal to rho q, rho x, then what do we say here? So we say f of x, y is what? Is a conservative. Okay, so this test, what is super easy, right? So it's super easy to, you know, to see that. Okay, all right, so that's it. That is for this section. So here's a very important sections, and it's also it's a very fun sections, right? So remember that they try to, you know, deliver the one concept is the conservative field. Then the fundamental theory of the line integral. So the conservative field doesn't matter what path, is a path independent. Okay, that's it. And so that's the lecture number 5 for this topic. All right, so it's nice to talk to you, and looking forward to talk to you in our next topic. All right, bye-bye.